Okay. Data 8, lecture 38. Oh, I'm being transcribed. How exciting. But I don't like that. I do. Okay, no, I'm not being transcribed. Announcements. Don't forget that there is a thread called the Student Materials Mega Thread on ED that has videos and walkthroughs of all of the discussion worksheets in lab, many of the problems in the project. It's a really good resource. It's been there all semester, but students are still discovering it, so maybe you will too. Lab 10 is optional. There are a few lab sessions tomorrow. There will be a video posted to the Student Materials Mega Thread. And you don't have to go. Most of the labs won't meet, but some of them will. So if you want to find the ed post, which is what this links to, describing the ones that will meet because you'd like to go to lab, you can do that. And optional means everybody gets attendance credit, everybody gets submission credit. Project 3 is due Friday. I've talked to many students about it. Seems like the ones I talked to are making progress. Have any of you started? Okay, excellent. You get early submission bonus for finishing tomorrow. We're doing our best to keep up with ed, and we have some office hours that are posted on the course website. On the course website. There is a course website. Excellent. So I think today they're online only. Yeah, but then we have some in-person office hours tomorrow. Doing okay? Sort of. Okay. The final exam is still going to happen in this course. It will be held in person on paper, kind of like in a normal semester. I acknowledge that it is not a normal semester. It's a particularly stressful semester, and a lot has changed. But I wanted you to know what's going to happen now, because I think what's even worse than having like a scenario you don't like is not knowing what scenario there is. So we've had extensive discussions with the staff, and yeah, this isn't going to change. I mean, if there's like an earthquake or a tsunami or something, then obviously it will change, but not because of the strike. So you can plan on taking an exam. There will be a review session next week. It will be fully online. And I would say, the staff for this course are just wonderful people. They really very much support the strike, most of them, but they also really support you, and they want to make sure that you have a good experience to the end of the course. And so they're going to help make sure that this final exam exists and is not a logistical disaster. So it's a little stressful for me, which means it must be really stressful for you. But we will do our best to kind of make sure that it's an exam that you're prepared for and to have it run smoothly. So the way this course is supposed to work is that you hear about concepts in lecture, and then you practice them in lab, and then you practice them some more in homework and projects, and then you're ready. Like we ask a lot of you, but we also try to prepare you to do well on the exam. We might have to adjust things a little bit in order to make sure that you're properly prepared for the exam questions that we ask. And we'll certainly have to adjust the format of the exam to make sure we can grade it with a limited staff. So that means you can expect a whole lot of multiple choice. Question? Well, what do I mean by adapt the exam exactly? I think for topics that you had less practice on, we'll try to make sure that we don't ask questions that feel like students wouldn't be prepared for them. So this is sort of a judgment call on the instructor's behalf. Like, we don't exactly remember what it's like not to understand this stuff, but we have a sense of what it takes to master material. And there was lots of material that we covered before the strike happened, and I think we did a reasonable job of preparing you to understand all that. But then there have been some topics near the end that you didn't get as much practice on as you normally would in a semester. And yeah, so how deep will we push to check your understanding might be adjusted as a result. So I would say everything up until the midterm is going to show up in some form on the final. It always does. After that, we covered confidence intervals, we covered regression, and all of that actually happened before the strike began. The strike mostly impacted the work on classification. Classification is pretty cool though, so we kept the project. We really want to make sure you make it through the project. If you're having trouble with the project, let us know. Come to office hours, or if you need an extension, let us know. But it's part of the data aid experience to work your way through that project. So I hope you find some time for it. Other questions about what's going on? Okay. I definitely feel for you. I know that, like, I'm trying to give you answers about what you have ahead of you, but I know that in other courses, like, you're getting less firm answers and stuff is changing all the time, and that's not how it's supposed to be. So I'm sorry, but hang in there. You were asked to take a survey near the beginning of the semester. There's a second part to it. You should have received an email already inviting you to take the survey. There's about a 10-minute survey that's part of a research project funded by the National Science Foundation to understand data science education and its impact on the university and how to do it well. It's important enough that we have funds to give you money in order to take the exam, so you can get a $5 Amazon gift card, or if you're feeling lucky, you can enter into a drawing for $50. But more importantly, this helps improve data aid, and this course is being offered in many other colleges and universities, and whatever comes out of this research will inform their courses as well. So it's pretty important. I hope you take the survey. Are you showing me that you did the survey, or you're doing it now? Okay, yeah, you can do it now. It's fine. But I'm not going to talk about the survey anymore. I'm going to give you an example. So we've gone through all this stuff, all these examples throughout the whole semester, but do they really apply to real life? Well, I've been claiming that they do, that all the techniques you learn here are applicable to the real world and real world data. But let's look at some examples where that's really true. So here's one I like. It's this lecture came from me listening to a podcast. And have you ever had a friend that's like, oh, I just listened to the best podcast, and then they spend 45 minutes telling you about it when you could have just listened to the podcast yourself? This is one of those moments. But it's because the first time I listened to this podcast, I thought it was so great that I made the whole class listen to it in this room, and they were bored out of their minds. So they gave me the feedback, why don't you actually give a lecture? So now I'm giving a lecture about the contents of a podcast episode, but it's not actually just about a podcast episode. The podcast is about a real world event that I thought was really interesting. It was covered, first in the British Medical Journal, and then in Scientific American, and then it found its way onto a podcast called Revisionist History, which is put together by a journalist named Malcolm Gladwell. And here's the premise. There was a doctor born in 1916, passed away in 2009, named Ivan Franz, who was the principal investigator of a major study funded by the National Institute of Health called the Minnesota Heart Study that linked diet, cholesterol, and heart disease. So heart disease leads to heart attacks, cholesterol is some chemical you can detect in people's blood and in food, and diet is what you eat. His son, Dr. Robert Franz, is also heart researcher. He's a cardiologist at the Mayo Clinic. And he received a message after his father had died in 2011 that said, Dr. France, I've heard of the possibility that there might be some very interesting data in your father's basement. This turned into a really interesting story in the medical community that helped understand the link between diet, cholesterol, and heart disease. And eventually there was a podcast made about it. And I will quote a little bit from the podcast because I liked it so much. Okay. It's a story of finding lost data. So there's a researcher named Christopher Ramsden who works for the National Institute of Health, which, among many other things, gives recommendations about what's healthy and what's not. But Christopher specializes in excavating lost studies, meaning finding data that was once collected but never published. And he's particularly interested in finding data that challenges mainstream government-sanctioned health advice. So even though he works for the government, which gives this government-sanctioned health advice, he wants to make sure that it's right. And so he looks for data that were collected that might challenge what the government is saying about human health. Because his premise is that failure to publish studies that do not confirm a hypothesis can mislead the scientific community. And understanding and publishing historical data can be a much more efficient and productive alternative to conducting new studies. Why would you run a whole study where you check people's health after you give them a particular diet when that was already done? And Christopher Ramsden doesn't just excavate lost studies. He also runs clinical studies of his own, and his research interest is on the effect of linoleic acid consumption on human health. Linoleic acid is what is the calorie source in vegetable oil, like corn oil and canola oil has this stuff called linoleic acid, which used to be before vegetable oil became so popular, it used to be something that people didn't eat a whole lot of. But now it constitutes something like 10 to 15% of the calories consumed today in the US. So it's now a major part of our diet because we put corn oil in everything. And he's trying to figure out how is that affecting humans. Okay, that's a sort of general research interest. But on the side, he also looks for lost studies and tries to bring them to light. Yeah. Yeah, this is a great question. Could old studies have outdated information that's no longer relevant? Certainly could. I think human biology hasn't changed too much since the 1960s, but all the other things we do in our life and what we're exposed to in our environment has changed a lot. So if you look at a human health study from the 1960s and there's some interaction with the amount of microplastics, well, there just weren't that many around back then, whereas there's a ton now. So there have been some things that have shifted quite a bit, but then there are some things that have stayed relatively the same, like how the human heart works. And so, yeah, you should be worried about this, but you just have to, instead of just throwing out old studies and saying, oh, they're old, so they're irrelevant, you should ask, do their conclusions remain relevant because they're based on things that haven't changed, or should we ignore them because they're tied up in things that have changed? Great question. Okay, so what does this have to do with the basement tapes? Well, it turns out that the father, Ivan Franz, who conducted the study, believed that data should never be discarded. And so much so that he didn't trust storing his old records with the university because he knew one day they'd throw them out. And so he collected all of the studies and all of the theses and papers that any of his students had ever written in boxes in his own basement. And when he died in 2009, his children inherited a house that was filled with boxes of old research. The university didn't want to store his data records forever, so he stored them himself. And that led to this scenario where after he passed away, his son, Robert Franz, got this message that said, there may be something of interest in your father's basement. And it had to do with the diet-heart hypothesis. So I'm going to do my best to give you the background on what the diet-heart hypothesis is, because I've listened to the podcast, but I also like read a few papers, but I'm not a doctor, so I'll probably get something wrong, but I'm going to do my best. This is about cardiovascular disease. So atherosclerosis is what's a phenomenon where the arteries narrow, and that means like an artery which carries blood from the heart, supplying oxygen to some muscle somewhere, gets narrower and therefore can't provide as much due to plaque buildup. This is particularly problematic for the arteries that feed the heart. So the heart is a muscle, it needs blood in order to have oxygen so that it can keep working. And if the arteries narrow too much, that leads to a heart attack, which is a lack of blood to the heart, which is the #1 cause of death in the US and many other places, and also worldwide. Cardiovascular disease is the leading global cause of death. 18.6 million deaths were attributed to this in 2019. The cause of cardiovascular disease is not known. There are many associations, though it's hard to establish causation. Associations between cardiovascular disease and high blood pressure, diabetes, smoking, obesity, family history, age, inactivity, and an unhealthy diet. The diet-heart hypothesis is about a causal link between what you eat and whether you have cardiovascular disease or whether you develop cardiovascular disease. So here's what we think we know. There's an association between unhealthy diets, physical inactivity, tobacco use, high intake of alcohol, and cardiovascular disease. You can just measure this by asking people in the population what they eat, how much they drink, and also checking to see whether they have cardiovascular disease. And each of these effects has some association, but the causal relationship is hard to tease apart because there are associations with so many different things. So for example, the World Health Organization thinks that 1.7 million deaths worldwide are attributed to low fruit and vegetable consumption. I'm not going to go into how they figured this out, but this is the kind of thing that health organizations want to know because they want to know what's the impact they could have by giving people more fruits and vegetables, or for example, changing their diet. High intake of salt is linked to high blood pressure. High intake of processed food is linked to obesity. Eliminating trans fats is widely recommended. Added sugar is linked to high blood pressure and obesity, which is linked to cardiovascular disease. All these different effects are there. So how do you know how much causal effect any one of them has on cardiovascular disease? Well, it's a hard thing to work out, which is why I said on the previous slide that the causes of cardiovascular disease are unknown. But how can this be? Like it's such a dangerous, terrible thing, and yet we don't know what causes it. Well, how would you figure out what causes it? You'd have to start with a hypothesis and then run a hypothesis test. So the diet-heart hypothesis, in particular, the one studied in the Minnesota Heart Study, is that replacing saturated fat that comes from dairy, so this is things like butter and cream and milk, with polyunsaturated fat that comes from plant-based oils like corn oil and canola oil and olive oil, reduces risk of heart disease, meaning there's some causal connection between what you eat and whether you develop heart disease. Hypothesis means we don't know whether it's true until we run an experiment. Now, Ivan Franz knew this was true in the sense that he never cooked with butter, never gave his children butter, always olive oil. He believed this was true, and he thought that he would spend a great deal of time and effort and the government's money in order to prove to everybody else that it was true, but he already believed it himself. Why did he believe it? Well, it turns out that if you replace saturated fat with polyunsaturated fat in your diet, this reduces the amount of cholesterol in your blood. Blood serum, it's like part of your blood. The amount of cholesterol in it is something that you can test just by drawing blood from somebody and checking to see how much cholesterol is in there. And serum cholesterol is associated with heart disease. The higher it is, the higher incidence of heart disease. So he already knew there was a causal connection between diet and how much cholesterol was in your blood. You know, there was an association between how much cholesterol is in your blood and heart disease. That's a pretty good reason to believe that replacing saturated fat with polyunsaturated fat will reduce your risk of heart disease. And in fact, this hypothesis is often cited as fact, even in an American Heart Association document in 2017, not that long ago. Someone said clinical trials that use polyunsaturated fat to replace saturated fat reduce the incidence of cardiovascular disease. But how would they prove this? Isn't that hard to figure out? Let's think about how you would run such a hypothesis test. How would you figure out that replacing saturated fat with polyunsaturated fat reduces risk of heart disease? What evidence would support that? You tell me. A randomized controlled experiment. Okay, so how does the randomized controlled experiment go? Take some people.
Take some people and tell them that some of them eat saturated fat and some of them
Okay, so you take some people and you say, you eat butter. You only olive oil. Go. Yeah, okay, this is fine. And then how long do we go? Your whole life. We need to figure out who develops cardiovascular disease and dies of a heart attack. All of a sudden, this is a hard experiment to run. So what was easy to establish was a causal link between blood cholesterol and what you eat, because it changes pretty fast. Like you can change somebody's diet for a month, say you're not allowed to eat butter for a month, and then like take their blood a month later, and that had been done. That work had been done, it was easy to do. This other piece of work is much harder to do, to be prescriptive about what somebody eats for their whole life. Why do we have to do it in a randomized way? Why couldn't we just ask people, like, do you eat butter or not? And then check and see whether they have heart disease. Because there might be confounding factors. Maybe it's the case that the people who eat butter also smoke and drink a lot. So the randomized controlled trial is the way to establish this causality, but it's difficult to achieve because to measure the outcome of whether somebody develops heart disease, you have to keep feeding them either saturated fat or polyunsaturated fat over an extended period of time. Years it takes to develop cardiovascular disease, and you need to check whether they have cardiovascular disease. How do you check whether someone has atherosclerosis? A narrowing of their arteries. It's a very invasive procedure called an angiogram, where they put a camera in your artery. This is not something you can do just because you're like interested in this problem, right? It's actually an invasive procedure that has high risk. So there's something else you could do, which is just wait long enough for some people to have heart attacks. But that might take decades. But that's what they were after in studying the diet-heart hypothesis. They wanted to design an experiment that would replace saturated fat with polyunsaturated fat and then measure whether the risk of heart disease was reduced by controlling people's diet for a long period of time. So the question is, did somebody literally count the number of heart attacks? Yes, in fact, there were many different sites where this occurred. So in the 1950s, they were planning this. I think in the 1960s, they were carrying it out. And several different researchers from major medical groups convinced the government, the National Institute of Health, that this was the problem of our generation, was to understand the diet-heart hypothesis, and therefore they should commission many different studies. And many of those studies were carried out in the open population, where they recruited people and they said, okay, you're part of the experiment, don't eat butter anymore. Did those people eat butter? They did. Did they always tell the researcher that they ate butter? Not always. Diet control experiments are notorious for the data not correctly reflecting what happened in the world because people don't always accurately describe what their diet was. So how on earth could you do this? How could you get people to always eat the right thing? Well, in Minnesota, they did something different. In Minnesota, they used a controlled population. This was an experiment planned for many years and then carried out from 1968 to 1973. How would you know that subjects will follow the diet they're assigned and report their consumption accurately? The answer in the Minnesota Heart Study was to use a closed population of institutionalized individuals who had been determined by the state that they were not fit to participate in society. Now, this might terrify you. Terrifies me that the governments would institutionalize people, but it happened a lot. And at that time, there were institutionalized individuals that might have been there by choice or might have been there not by their own choice, that lived in institutions, meaning they were fed out of a cafeteria for every meal. And they received permission, this Ivan Franz fellow and his research group received permission to conduct the following experiment. Randomly separate the individuals in these institutions into a control group where food was cooked in butter and served with butter as usual. This was Minnesota, which has a huge dairy industry. There's a lot of butter there. I grew up there. The state fair has a human carved out of butter as one of their main fixtures. Butter is a big deal and it's in their food. But in the treatment group, they cooked the food in vegetable oil instead and was served with a corn-based substitute for butter called margarine, which is basically, butter is a glob of fat and margarine's a glob of fat, and they both are kind of whitish yellow. They're sort of similar, except for butter tastes better. I mean, that's subjective, of course, but it's also true. Okay, so the treatment group had a different diet. And this was a double-blind study, meaning neither the subjects nor the people delivering the food, the servers who gave them their food, knew whether the subjects were in the treatment or control group. Now, these are people, they might have figured out that their food didn't taste delicious, but every effort was made to not inform people that this study was going on or what group they were in. Now, the chef had to know, right? Because they had to decide what was served to whom. But then that was handed off to the food server who interacted with the subject, the person in the institution, and neither of those knew what kind of diet the person was receiving. And day after day, they would either receive food cooked in butter or food cooked in vegetable oil. This seems like an incredibly unethical study. This is one of the things about finding historical studies, is that they did things back then that would not be allowed today. You should be worried about the ethics of conducting a study like this. Like, is it appropriate to experiment on people who have been institutionalized? Is it appropriate to change somebody's diet? What if you're changing their diet in a way that might actually make them sicker? All of these things should be huge concerns. Now, people believed the diet heart hypothesis already before they ran this experiment. They thought that by changing the butter to margarine and using vegetable oil instead of butter, it would improve people's health outcomes. So they thought that the control group was just the same as what was already happening, and the treatment group would make people more healthy. So they weren't intentionally giving people a treatment that they thought would make them sicker. It's just and not that it will, but I'm just saying that was not the issue. The issue was that they were experimenting on human beings without their knowledge. Question in the back. Oh, good question. So could you run an experiment on animals instead of people and see what the effects were there? I'm sure these kinds of experiments have been done. I don't know much about it. It's a good suggestion. But I will say that that human diet is very different than the diet of any animal. And so it's a little bit difficult to generalize the effects of diet on health when you're feeding a human than if you're like feeding a rabbit or a mouse or something like that. So biologists think a lot about like what's similar and what's different between different species, and therefore what can we generalize and what can't we? And in this case, they decided like if we really want to know whether the diet heart hypothesis is true or not, we need to run the experiment on people. Uh-huh.
If it's already developed experiment by people, how would you ever create an experiment where you can like separate the result of structural humans without ever testing?
Yeah, the question is if something like this is always unethical, how would we ever run an experiment? And this is a great question. I think that ethics has to deal with, what's happening to the subjects and is that right? But it also has to think about what happens to society. And if we could determine what impact diet has on our health, that might save millions of lives. So that's also part of the discussion of ethics I think is relevant here.
I was just wondering whether this made potentially challenging assumption that institutionalized individuals are representative of all populations.
A great question. Is this assuming that people in an institution are somehow representative of the rest of the people that are in the open population? And this is certainly an issue with this study. The people that are institutionalized are not a random sample from the general population. And in fact, they're chosen for particular reasons. The assumption made here was that their heart and their reaction to diet would probably be similar, because the reason they were institutionalized was not because of their heart health. But I'm sure that other things were different, like the amount of exercise that they got and exposure to environmental factors. So it's certainly a concern. But that's why there were many studies run, and many of them were run in the open population. But this one was run in a closed population because it allowed for more control, even though it wasn't as representative. Uh-huh. The question is, what about an A/B test using observational data? When you use observational data, you can establish an association, but you can't establish a causal link, because it might be that the association you observe is due to some other factor, some other association, like people who eat a lot of butter also drink a lot of alcohol. And it's hard to control for all of those confounding factors at once in an observational study. So that's why, if you really want to establish a causal link where you know that changing the diet will reduce heart disease, as opposed to just people who have this diet have more heart disease, then a randomized controlled experiment is a good way to do it.
So people are occasionally experimenting on top of that, right? It's sort of, I don't know how invasive it is.
Yeah, good question. Are people ever experimented upon without their consent? And if so, why? In the modern era, there's something called an institutional review board, which is a group of people that evaluate the ethics of an experimental study that involves humans. And their criterion is pretty simple. You have to inform people and get their consent unless there's an awfully good reason not to, like it would spoil the experiment otherwise. So my guess is that this wouldn't pass that test in the modern era. Like they'd say, you have to get people's consent. But the 1960s was a different time. In the back. The question is kind of like, what's the modern era? Like, when did we stop experimenting on people? I'm sure somewhere in the world, people are still experimenting on other people without their consent today. In the United States, educational institutions, I don't have a really good grasp on the timeline, but I feel like really rigorous review. Yeah, I didn't hear about it until later than the 70s. I feel, I wish I knew the answer to that, but I don't. Mm-hmm. Yeah, this is a great question. So aren't there still confounding factors? Like what about genetic predisposition to heart disease? How is this factored into this experiment? The idea of randomization, which is that you take some group, in this case, institutionalized individuals, and randomly separate them into treatment and control, is that even though there might be variation within the whole population of genetic predisposition, of alcohol use, of smoking, that both the treatment and control groups will be representative of that distribution in more or less the same way, because they're both large random samples. So in that way, you end up knowing that the groups are similar in terms of their genetic predisposition, in terms of everything else. The only thing that you know they're different about is that all these people ate a lot of butter and all these people ate a lot of margarine. Really cared about the double blind, didn't want people to know that they were getting margarine instead of butter. But the dairy industry was so strong in Minnesota that they had passed a law that said butter can be cut into beautiful little squares, but margarine must be cut into triangles in the state of Minnesota so that people would know it wasn't butter. At which point, Ivan Franz lobbied the legislature of the state of Minnesota to pass a special law that said for his experiment only, they would be allowed to cut the margarine into squares so that it would be indistinguishable from butter. What was the outcome? The study continued for 5 years, tracking both subjects' cholesterol level and health outcomes. Here's a quote from the podcast. The patients on the vegetable oil diet did end up with lower cholesterol than the people who ate food cooked in animal fat. That part worked according to expectation, but the vegetable oil people didn't live longer. At this point, they hired, they took on a statistician, a man named Steve Broste, to write his master's thesis using the data. And they brought him in because he knew a lot about advanced statistical techniques. And Malcolm Gladwell interviewed him. And he said, you know, they were hoping that with some new statistical technique that had just come out, they might be able to either understand why the results came out the way they did, or after some adjustment for explanatory factors, that maybe the results would change. The results didn't change. No matter how they looked at the data, it turned out the people on vegetable oil diet didn't live longer. And when Broste talked to Ivan Franz, Franz just shook his head. Steve Broste said, because he's still alive, Steve Broste was just a master's student, like a young guy during this. He said, I remember him just expressing his bewilderment at how it could possibly have happened. Okay, I'm going to read one more quote from the podcast because I like this one. In 1989, 15 years after the Minnesota experiment ended, Ivan Franz finally published his results. But the paper was vague and didn't really go into detail, as if after thinking it over for 15 years, he still couldn't make sense of what happened. This was a man who never ate butter, who regularly checked the lipid levels of his children's blood. This was what he believed in, and to test that belief, he spent years and millions of dollars designing the perfect clinical trial. And after all that, the results were equivocal. And so he put a box full of all of his old data in his basement because he didn't believe in throwing anything out, and he retired and died in 2009. And his study was all but forgotten for a quarter century until his son Robert got a call out of the blue from Christopher Ramsden. There may be something of interest in your father's basement. And the data was recovered. Robert Franz returned to his childhood home multiple times, searching the basement for records. Upon his third trip, he sent an email to Ramsden saying, Eureka, I have found it, because he discovered a whole chest full of IBM computer tapes, including records of the 9,423 people who were participants in this study aged 20 to 97, all living in state mental hospitals. Actually, I forgot this earlier, but there was one nursing home included as well. So there's a group of people that are a little bit on the older side. And this was the largest experiment of its kind, of a highly controlled study to test the diet-heart hypothesis. And the results were never fully published because they didn't confirm the hypothesis. This has now been reanalyzed. They got the old data and they wrote a paper in 2017 or something, 2018, I forget the year, very recently, which had the following conclusion, that replacing of saturated fats in the diet with linoleic acid effectively lowers serum cholesterol, but does not support the hypothesis that translates to a lower risk of death from coronary heart disease or all causes. Findings from the Minnesota coronary experiment add to growing evidence that incomplete publication has contributed to overestimation of the benefits of replacing saturated fat with vegetable oils rich in linoleic acid, that's corn oil and canola oil. So it turns out that an experiment that wouldn't be allowed to run today, let alone the massive cost and the years that it takes, contained the data that described whether you could establish a causal link between this diet substitution and how long people live. So let's take a look. They also found Brosti's thesis in paper form in a box that was like, was getting yellow, and it contained this graph, which is probably hard to see, but this is an aggregate over all the subjects in the experiment, their time in days. So like how long they were in the experiment, from 0 days up to 1,600 days, which is several years. And on the y-axis is the cumulative proportion of death. Sorry, this is all about death, but that's what you have to study when you want to study the diet-heart hypothesis. And so what we see in this chart is a line for people on the diet, meaning they had margarine, and a line for people in the control, meaning they were eating tons of butter. And the lines have a similar shape, but it's the diet line that's higher, and up means more people died. So what happened in the experiment is that when we randomly split the two groups into diet and control, actually more of them died within any given time period of the experiment than in the control group. Yeah. This is a great question. So to conduct a hypothesis test, you need to pick what you're going to measure, right? And like what statistic you're going to calculate. This is just a data visualization. This isn't kind of like a final conclusion where we're trying to compute a p-value. But I think it's a useful data visualization because it shows that the longer you run a study, the more people have died who are subjects in the study. And you can just see the sort of rate at which people are passing away is slightly different for the two groups, not particularly different. Out here it's different, but there just aren't that many people in the study at this point. So I would just sort of ignore that part, focus on the part where most of the people are in the study and see that, yeah, I mean, the shape is not that different, the slope is not that different. And if you had to pick which one's worse to be on, the diet or the control, the diet looks worse because it's overall higher. But in order to, for example, decide whether the difference between diet and control is just due to chance or whether there's really an effect here, we'd have to pick a one number summarization. So we haven't really done that part yet, but we will in a minute. Mm-hmm. This is, yeah, deaths overall. They also measured deaths due to heart attacks. Yeah. Okay. Ha. Yeah, that's a great question. Maybe it's like because they were so used to eating butter that switching was the problem or something like that. But that's definitely core to the hypothesis. The hypothesis was if you switch out butter for vegetable oil, that will reduce the incidence of cardiovascular disease. The hypothesis didn't really say much about why or what would happen if you ate it for your whole life. Yeah, I think they were in fact experimenting on exactly the hypothesis that they wanted to test. I couldn't find all the data because these are like data about people. This didn't get republished on the internet, but I did find this one table that summarizes the data. And I think this is enough for us to run an A/B test. So let's do that. What this table says is that for each age group within the study, how many people were placed in the diet group, that's the treatment group, they got the vegetable oil, and how many were placed in the control group, they ate a lot of butter. For 1, 2, 3, 4, 5 different age ranges, this is greater than 65 years old when they started the study. This is the number that died during the study. So basically, all the people who were less than 35 at the beginning of the study lived. I mean, not all. There were 3 that died, but there were 7 that died in the control group. But the difference is fairly, like the numbers are really low. Whereas the people that were greater than 65 at the beginning had a much higher rate of death. And here we see a real difference. It's like 19.9% on the diet versus only 16.9% in the control. So there's a 3% difference between the fraction who died in the treatment group versus the fraction who died in the control group, where there are about 1,000 people in each group. Is that difference enough to say that this is statistically significant, or could that amount of difference be due to chance? That's something we actually know how to run in this course. We could just run a permutation test. So let's do that. Here's all the data. Now, this table is a summary. It shows you the total number of deaths. This is also the deaths from coronary heart disease, but we'll just focus on deaths of any cause. This doesn't have one row per subject, and that's what we're used to, right? Is a table where you get like one row per individual. But we could actually use a little bit of Python code in order to take this summary table and convert it into a table that's one row per individual. Here's the trick I'm going to use, is that if I know there's 3 people who are in the diet group and 12 people total, then I can come up with 3 people in the diet group and 12 people total just by using a range. So I'm not going to go through all the details, but I'll tell you that this is a snippet of code that takes that summary table and turns it into a table that has 9,423 rows, one for each individual in the study. That gives me their age, whether they were on the diet or in the control group, whether they participated, this is always true, and whether they died. That's true for some and false for others. This is exactly the kind of table that we can run a permutation test on, where we can randomly permute the condition they're in and see what is the difference between the fraction that died in one group versus the other. So first we need to figure out what our observed statistic is. If we take this subjects group and group it by age and condition, then we see just a re-expression of that original summary table. So among people that are age 0 to 34, there were 1,337 that participated and 7 that died in the control group, 3 that died in the diet group, et cetera, et cetera. We can use this information to establish the hazard rate, which is just the fraction who died in any group. And here is the statistic that I'm going to measure in order to decide whether the difference between the 2 groups is large enough to be considered statistically significant. I'm just going to look at the hazard rate in group 1, which is the ones in the control group, minus the hazard rate in group 0, which is the ones in the diet group. Overall, the rate difference is tiny, 0.5%. That's the observed difference. But if you look at particular age ranges, you see a tiny observed difference for 0 to 34, but a large observed difference of 3% for people 65 plus. So this was the difference between 19.9% and 16.9% that we saw on the slide. And that's enough to run a hypothesis test, which I will do. For each age group, I'll ask whether the difference in hazard rates in the two different conditions is large enough to be considered statistically significant just by running a permutation test using exactly the same code that we always use in this course. And it turns out that the observed absolute difference in hazard rates for people aged 0 to 34 is not very large. And so you get a p-value that's pretty big, meaning that there doesn't seem to be any difference between the treatment and the control. And same thing with age 35 to 44, same thing with age 45 to 54. The only case in which there is a reasonably large difference in hazard rates is among people 65 and older. But even then, we don't see a p-value below 0.05. So it looks like this could have just been due to chance. And even if it wasn't due to chance, it's in the wrong direction. More people died eating vegetable oil than they did eating butter. Yeah. What's that? What's the point of the study? I guess the point of the study is that all those people that are out there telling you that you should stop eating butter and you should start eating vegetable oil don't have a justification for it. Because if you run a careful randomized controlled experiment to test that it actually helps you live longer, it turns out it doesn't help you live longer. And if this study had never been published, then we wouldn't have that evidence. Okay, thanks for listening.